So we're going to be looking at topic C2, and we're going to be looking at bonding, ionic bonding and covalent bonding and how that works. And I'm going to share that with you on the whiteboard. So what I'm going to do is get rid of this camera so I can talk to you properly. So C2, we've got bonding, properties of substances, structural bonding in carbon, and this bit we don't do in trilogy. What we're going to look at today is these things here. So chemical bonds, ionic bonding, covalent bonding, and metallic bonding. So let's press on. Okay, so let's look at ionic bonding. Okay, there are three sorts of bonding you have to know. This is what we're going to start with: ionic bonding, and then we look at covalent and metallic. Metallic won't take very long, and it's going to sound confusing, but once you understand the ideas behind it, it's not too bad. So what are the differences between ionic, covalent and metallic bonding? So ionic bonding is to do with this word here, ions, and we're going to unpick what that means. How do you know if it's ionic bonding? Because there's always a metal involved. Okay, so if I was to say to you sodium chloride, you know sodium is a metal, and if you didn't, you could see it's in the left-hand side of the periodic table. It's going to bond ionically, usually to a non-metal. Covalent bonding is between non-metals. Okay, so if I said to you hydrogen chloride, HCl, you know hydrogen and chlorine are non-metals. That's going to have a covalent bond between them. And metals, metallic bonding is slightly different. That's how metals are joined together. We'll look at that separately. Okay, so first key thing, ionic bonding always involves a metal. Covalent bonding never involves a metal. Okay, ionic bonding is to do with ions, and we'll talk about the transfer of electrons. Covalent bonding is to do with sharing electrons. So let's move on. Let's crack on to ionic bonding. Okay, it's going to look quite complicated, but I'll talk you through it. It's going to be fine. Okay, so we're going to be looking at sodium. Sodium joining to chlorine. Okay, sodium is in group 1 of the periodic table, the symbol's Na. Chlorine is in group 7, the symbol's Cl. And if you look in the periodic table, you'll see your sodium atom is in group 1. It's got 1 electron in the outside shell. Look, 1 electron. The other shells are full. Forget the other shells. Don't worry about them. Don't worry about the nucleus. It's got 1 electron in its outside shell. Chlorine is in group 7. Look, it's got 1, 2, 3, 4, 5, 6, 7 electrons in its outside shell. Now, the atoms, to be stable, want to have a full outside shell. The easiest way for the sodium to get a full outside shell is to get rid of that 1 electron. Then the next shell inside is full. It's got its 8 electrons in. Chlorine wants to have a full outside shell. Chlorine's got 7 electrons in its outside shell. The easiest to get the full 8 electrons is to gain 1 more. It's easier for sodium to lose 1 because there's only 1 in there. It's easier for chlorine to gain 1, make 7, add in 1 makes 8. So all that happens is that outside shell electron goes from the sodium to the chlorine. Okay, and imagine that. Move over to here. Look. So all this is that's the sodium, exactly the same, but with that outside shell electron gone. So we've now got a full outside shell. 1, 2, 3, 4, 5, 6, 7, 8. It's this one. It's that shell there. That's where it's come from. Okay, the chlorine, look, has got that electron from sodium, so it's now got a full outside shell. Look, 1, 2, 3, 4, 5, 6, 7, 8. Both the sodium and the chlorine are happy because they've got full outside shells. Now, we don't call them, these are atoms because they're neutral. They've got the same number of electrons as protons. These things, we now call them ions, I-O-N-S, because they've got a charge. Look, the chlorine has gained a negative electron, so we give the chlorine a negative charge. So it's a negative ion. The sodium has lost a negative electron, so what's left behind is more positive. It's got more positive protons than negative electrons because it's lost a negative electron. So overall now it's positive. Okay, and opposites attract. You know, you've heard that before. Opposites attract, so they stick together, and that's what an ionic bond is. Okay, and that in an exam question, let me just rub that out. In an exam question, this is what you get. You get something that looks like this. Oh, you get something that looks like this. Okay, and you have to look in the periodic table, and you might have to put the outside shell electrons in. Okay, if it's in group 1, it's got one electron in the outside shell, group 2, 2 electrons, and so on. And then you have to show the electron going from one to the other, and then you have to show that that leaves a positive charge, that leaves a negative charge, and that is what your ionic bond hit is. That's another way of looking at it here. Look, here's the outside shell electron, it skips over to there. This has then got a positive charge, it's got a negative charge. Here's our electronic arrangement, the arrangement of electrons. Look, 2 in the first shell, 1, 2. 8 in the next shell, 1, 2, 3, 4, 5, 6, 7, 8. 1 in the outside shell. Look, there she is. That's all it is. That's the arrangement of the electrons. And that, in a nutshell, is ionic bonding. The positive ion sticks to the negative ion. Quite a straightforward example, because the sodium wanted to get rid of 1, the chlorine wanted to gain 1. So it's just a simple swap. Let's have a little looky at a slightly more complicated example that is still not that complicated. Okay, this is magnesium oxide. Oh, where's my pen? That's magnesium oxide. Okay, with magnesium oxide, the magnesium is in. Let me scoop out a bit. Magnesium. Okay, it's a nucleus. Magnesium is in group 2. It's got 2 electrons in the outside shell. I'm not going to draw the other electron shells. Okay, oxygen is in group 6, so it's got 6 electrons. Look what I'm going to do, I'm drawing these electrons as dots. It's a dot and cross diagram. Okay, 6, is that 6? 1, 2, 3, 4, 5, 6. Okay, that's just the outside shell. I've got my crosses, got my dots, dot and cross diagram. Right, so the magnesium wants to get rid of that electron, and it wants to get rid of that electron. This oxygen, this one here, wants to gain 2 electrons. So simply speaking, that one goes there, that one goes there, you bung them in. Oh look, this one's got 1, 2, 3, 4, 5, 6, 7, 8, full outside shell. This one's lost these 2, so the next shell in is the full one. Let's look at that on a slightly more professional drawing than my rubbishy one. Oh look, here's my magnesium. Okay, it's lost 2 outside shell electrons, so the outside shell is now full. And here's my oxygen, it's gained, look, there it is, it's gained 2 electrons, so its outside shell is now full. Look, it's got a 2 minus charge because it's gained 2 negative electrons. Magnesium's got a 2 plus charge because it's lost 2 negative electrons, so it's got 2 more pluses than negatives now. Okay, if you want to get really complicated, let's look at this example, because I'm sure you do want to get complicated, but it's not really that bad, to be honest. It's not that complicated. Calcium. Calcium's in group 2 of the periodic table, and chlorine, so we're going to make calcium chloride. Okay, rubbish drawing from me time again. So let's look at calcium. Okay, here's my nucleus. Let's not do that. Let's do black pen. Right, here's my nucleus. Here's my outside shell of calcium. It's got 2 electrons. It's in group 2. It's got 2 electrons. We're going to join it to chlorine. Right, here's chlorine. Chlorine's in group 7. So look, 1, 2, 3, 4, 5, 6, 7. Oh no, the chlorine needs an extra electron. The calcium has got 2 more than it wants. What happens? Right, well, this electron can go in there. That that chlorine has now got 1, 2, 3, 4, 5, 6, 7, 8 outside shell electrons. It is happy. What's the charge on it? Well, it's going to be negative because it's gained an electron. The electron's a negative, it's gained an electron. Whoa, problem. Look, we've still got this one in the outside shell. What could we possibly do? I know, let's draw another chlorine. Here's my chlorine. 1, 2, 3, 4, 5. What group is it in? 7. 1, 2, 3, 4, 5, 6, 7. What's going to happen? Oh look, this electron can come and whack in there. Okay, so that means that is now a chlorine ion. It's negative, it's gained a negative electron. The calcium has lost 2 negative electrons, so the calcium is now a 2 plus ion. Okay, so what do you think the formula of calcium chloride is? 1 calcium. Oh look, 2 chlorines. One here, look, chlorine. So calcium chloride is CaCl2. Yeah, bit of a light bulb moment, perhaps. Okay, so 2 electrons, 1 gone to each. And that's as complicated as it gets, and that is ionic bonding. You know, you've swapped electrons from one atom to another, and we don't call them atoms after we've swapped, we call them ions. Okay, simple as that. Let's go back, basic facts with ionic bonding. Okay, just remember what I said. If it's got a metal in, right, ionic bonding, if it's got a metal in, it's ionic. Ionic means swapping electrons. Okay, the electrons go from the metal to the non-metal. Okay, and that, when they do that, you've then got a charge on your atoms. We don't call them atoms at that point, we call them ions. Okay, well done.